So what's the plan? We'll be talking a little bit about what open science is, and it's an umbrella term, so we may all have different understandings of it and what it entails, so it will be interesting to see that. Then borrow a little bit from the business world, or the real world, where people make things, manufacture things, want to make things better, improve quality, and best practices research is kind of a method mostly used in pharmacology in order to continuously improve, a quality process, and you can apply it to science as well. So I will briefly introduce this method because it's a method you may use yourself when you're leading your group or participating in it, and also apply it a little bit on a few selected components of doing longitudinal research on birth trauma. How do you detect, how do you define best practices? How do you find and evaluate those? And how do you incorporate elements of best practices in your own work? And I will be sampling some, some examples that I encountered, but you're really welcome when you come to best practices around registration, around the derivation chain, effect size expectations, overfitting issues, and code reproducibility. If you already know of best practices or wonder whether this is a best practice that you know, also please come forward and suggest that. Ending towards a strategy in order to be able to do the best possible research. So let's see how far we go. And I wanted to take you first a little bit into my motivation for talking about open science and sharing this with you, introducing this in this class. It was also an explicit demand from the costs committee to include open science in this training school. And I think it could be integrated well. So I really welcomed that opportunity. But also in my university and other issues, I try to see how open science can really be used in order to do what we already want to do, namely to continuously improve the quality of our work, the veracity of our science, the accessibility of science. But these are no new ideas. This is a very nice cartoon that's being made. If you go to that website, Matteo Farinella, biomedical researcher and a very good cartoon artist. I won't go through the whole cartoon, but he made a cartoon out of a letter that Bernard Forscher wrote back in 1973 in the journal Science. And so there's this journal that calls itself Science. It's a little bit presumptuous, but yes, and people read it. And it is kind of a fairy tale. It talks about a country where people were making and building bricks, and it's supposed to stand for what people in science are doing, and traditional science where the scientist who has an idea about how the world works and wants to test it, and then as a scientist also builds like his own or her own microscope or another apparatus or a procedure that would collect the data, the bricks, in the precisely the shape and form and amount that you need in order to test your idea, to test your theory, and to build your idea about the world. And then what he describes is that became so successful, and people started to actually listen to scientists who worked in that way, that they gave even more money, and scientists began to make more efficient brick making enterprises, and that stands for like the big data movement, where large cohorts, large data collection facilities with lots of brick makers, which refers to early career researchers, PhDs, postdoc researchers, focusing on producing as many bricks as possible. But are we, losing our way when we see all the bricks piling up, but nobody thinks, are we actually, what kind of building are we actually making? Is that brick making process itself starting to become a problem? So I think this is a very powerful analogy, where sometimes when we seek an important pursuit, that science is an important pursuit, that's why we came out of our beds this morning, may sometimes turn against itself, and we lose sight of why we are actually doing it. So we might focus more on, producing more data, or producing all kinds of papers that we can get accepted in journals and then fill our dissertations with, or our CV list with, and then we see ourselves as successful as our publication list is becoming longer, and these papers itself, they have to be read by people, but who has time to read all of that? So asking those questions, and I think, probably if you have, lie awake at night, perhaps these similar thoughts may have occurred to you. That can lead to sometimes a little bit of self-doubt. So how to deal with that? My solution is to all of the things that are threatening us at the moment is to use copious amounts of black humor, and fortunately, people on the internet are also using that. Richard Riley, who's, if you are on Twitter, and he's also on Mastodon, if you is a great guy to follow. He's a statistician specialized in individual participant data meta-analysis, but also very strong on all kinds of methods, but also has a very critical pen. And here he writes, the academia career bootstrap, get existing data, call it big, don't worry about the quality, form questions based on the variables that you find in this data set, analyze until you find something novel in that pattern of data. Do some sensitivity analysis. You can always find a sensitivity analysis for anything that doesn't change the results. Publish it, inform your communications manager of your university and media, and then repeat until you get tenure and a chair and you become professor. Which is, it's a little bit cynical, but it sounds like the game plan that sometimes also gets taught to researchers like you, like this is the way to go. And sometimes you have to look really, really hard at people's careers to see that this may actually be oversimplifying things to some extent. I also found quite poignant a tweet by Maarten van Sweden, another statistician, who wrote, imagine how exciting every new analysis result would be if you didn't know about p-hacking, data dredging, confounding, colliders, measurement errors, missing data, Simpson's paradox, and the list goes on. And this may actually be the joy that, older people like myself have been able to enjoy. And so you're missing out on this, because you know better now. And so you'll be kind of deprived of that joy of looking at the data sets, finding something significant, and then thinking, I can publish this. No, yeah, sorry. That's the burden of knowledge. Yeah, we have to find our satisfaction elsewhere. I think that's the idea. It also is kind of a warning against making too much out of data, but also making too much out of theory, because we can easily fool ourselves. And I think from this common experience that people, if you have a clear moment at night, you're thinking a lot of these things. And many people around the world are doing this. They feel stuck in the system. Think, but I cannot escape. I have to publish these papers. My tenure committee is looking at this, or my PhD committee. So how to deal with this? I guess from this collective unease about the enterprise and whether it brings any good, the open science movement kind of gained steam, greatly helped by not by the senior colleagues, but greatly helped by funders and governments who were pumping all years of money in the system, and we're seeing that you get diminishing returns on that investment, just by the way that researchers don't really have a clear plan to do something that is really useful. So so it's like bottom up and very top down, which okay, nice music, dramatic moment. So you have this movement, this push from bottom up, top down, and then the senior stuff just cannot do anything else than just crumble under that weight, and that's what's happening now. So I wanted to invite you to again go to menti.com and just put down open science practices that you already know or heard of or are aware of. Oh, should I? Yeah, but the number will also be on the screen in a moment. For the people online, can you see it, or you can online go to menti.com and put in the code. So yeah. So anything that you associate with open sciences or practices that you already are doing, thinking about, see other people do. Oh yeah. Pre-registrations coming up. Uploading syntaxes, like open methods, protocols. More pre-registrations, open data.
Sharing data.
Sorry?
Sharing data.
Sharing data, yes. Yeah. So, open access publications. Supplemental data. That's a good one. Yeah. Profiles. Events, public as a scientist. So I wondered profiles. So who put in profiles? Who just interesting Oh, sorry, I have to change the share screen. Yeah. So who wrote the profile? No. Nobody.
From the. Online group.
Okay. So what do you mean with profile?
Maybe people from online.
Oh, perhaps one. Oh, yeah. Okay. No. So online, did some? I was just curious to know what is meant with profile. Oh, intriguing. Art programming, European social survey. So you put it out there, I believe.
Everything open, from the protocols, the methodology, translations,
Yeah.
every step.
So that whole project, which is a huge project, is planned from the beginning to the start.
To use it in their research, like in data analysis.
Yes, so that's enormous brickyard that's being created there.
It's not like longitudinal, but it's like cross-sectional after 3 years, then you can see the program behavior, people opinion, things in different countries.
Yeah. So yeah, that also relates to some of the practices relating to open data or uploading your data, is that reuse of data is very much part of the open science movement. It's also there no manipulating results. That's an interesting one. So who responded? Yes, Christian, yeah. Yeah. So part of these practices, like pre-registration, increase the trust and is done through transparency. Yeah, of course, then it assumes that people will be going over your pre-registration when they look at your results, which is a yeah. For meta-analysis, this is great to have access to the original data, original documentation, to be able to make much better meta-analytic studies. So there's a lot of collective knowledge already about many open science practices that can be used to improve research. I'm now switching screens again to the presentation for the people at home. Where is it? Here it is. So actually, when you go to the Foster Open Science website, there's a whole taxonomy you can find out there. We won't go to it in detail because it's much too much time. And they have the website here where you can learn all kinds of stuff because it's open about many of these aspects of open science. So it has the open access there that you mentioned, the open data, making data open, reproducible. We will talk about this a little bit more. How you actually define open science, because when is it open, when is it closed, are there degrees in it? When you start to reward certain open science practices, we need to have a common definition. So this is important work relating to evaluation, guidelines, policies, and projects to actually support and foster this work, and developing all kinds of tools to facilitate, make it actually more easy to do it in an open way than to do it in a non-open way. Yes, you had a question.
It's listening to ORCID as well. Can you sign into this site with your ORCIDs?
The Foster Open Science site is open, so you can just read it without having to log in. But of course, ORCID, if you may have heard about ORCID, which is kind of a number tied to your identity, and which is persistent, so not linked to your university, or if you marry and take the name of your wife, then it's still you keep the same ORCID. So this is helpful for transparency and documentation. So actually, that is also part of all of it, because one reason. So one important realization behind this, and why this open science thing is so big and all encompassing, is that of course people have wondered, pre-registration, open data, open access, it's self-evident that is better than non-open. So, if that's true, why didn't we always do this? Or why weren't all data open, or at least accessible, or well documented? Or why were people fooling themselves and their readers by p-hacking or other manipulations? Because we clearly know that that's a worse practice than doing not so. So there must be mechanisms that keep us, or our predecessors, from engaging in the better behavior. So we need also to think about not only what is the better process or practice, but also to think about what is the ecology, the culture, the environment, the rewards mechanisms that kind of determine our behavior and make it more difficult to do the open science thing, and make it easy to kind of be less transparent and less sharing and less trustworthy. Yes.
My mind is in that it's not always voluntary, because we have the protection laws. It also creates barriers that the organization the participants behavior that will be there, they're even anonymized. So it's also a mechanism created that is challenges. I think it's not always.
Yeah. So you're referring to the difficulties in engaging in open practices, for example, because there are other values, other ethics at play, like protection of privacy of your participants in our field. I don't think we can put our data sets just openly accessible, because people can be easily identified if they combine the location, the hospital perhaps, and the kind of, some parameters about the birth or the baby. Yeah, you can figure out who it is, and that will invade privacy, of course. So, but these are practical matters. So part of the open science projects and infrastructural projects out there are trying to tackle also these barriers towards more open science practices. But it's from the same realization that, okay, we know that some practices are better than others. What is keeping us from them? Some of them may have to do with privacy and protection of data. So we need to think smart about how to tackle those. Some have to do with, how the economics of academic life work, where, publications is a currency, where citations are a currency, where the impact factor of the journal that you're publishing is a currency. And these currencies may not always provide incentives towards transparency and trustworthy reporting. So yeah, this economy of academia is also something that companies may see as a business opportunity. So we were talking about it over lunch, is that, you know, if you go to a journal that publishes study protocols, they will happily do so if you pay €4,500 to a Swiss bank. So, and of course, you know, don't mind the Swiss, but it's a lot of money.
There are different banks for always.
No, but funnily enough, many of these publishing companies are legally in Switzerland. So it's important to broaden your view. So you sometimes see policies that's sort of our university now says, you know, open access is the way to go. They also built kind of support for helping with open data, etc. And they had an institutional account on the OSF. So all these steps to facilitate this also point into the right directions, but there are still lots of other things that are still working in the other direction, and also often very prestigious colleagues saying, "Oh, this also has downsides for people's careers, and we are not perhaps we may be rewarding people who are very good in filling out all the boxes and putting OSF pages, and we may not be selecting for the brilliant minds that have these wonderful ideas that are always true." So yeah, there's some discussion going on. Just very briefly, it may sound sometimes that the open science movement is kind of based on dominantarian ideals. The European Union has very strong policies regarding open science. So liberal democratic values seem to be underlying many of these policies. And sometimes you read policy documents and then you will see that it's true. But there are also other schools of thought that would point towards the way of open science, like a more pragmatic school of thought. You know, what's the most practical way of engaging in research? Is, for example, having everything that's being written openly accessible, available, or being able to reuse data that already has been collected, so you don't have to collect it anew, which is just very pragmatic and even economical, without even having to think about the liberal democratic values that underlie this. Infrastructure can be a reason. We want to engage in science, and we want to make it as easy, as seamless, as effortless as possible. So yeah, building and sharing tools that reduce the effort of doing research can be a great value for all of us. There's a public school that most research is being paid out of the public means, taxes. So it's being funded out of a idea that it's in the public benefit to have science. So many of the things related to open science is also to increase, to maximize the public value of work, so that also people outside the universities can read work, that there's a wider participation in science. For example, citizen science is also subsumed under open science. And there is also a school of thought that focuses on that the actual metrics that we now currently use in order to evaluate research and researchers are actually quite flawed. And we know this for a long time. Impact factor, for example, of journals that you publish in, they are a terrible, you know, if you look at it from a scientific metric point of view, they are a terrible metric to represent to say something predictive about the quality of the studies that appear in a journal, because it's heavily influenced by, you know, a fraction of papers that get cited very, very many times, whereas, you know, 80% of the papers that appear in the same high impact journals are not cited that much as a possible measure of their scientific value. So we know this, and still is often being used in evaluation. Citation is the same. If you write a meta-analysis, then you're in luck because you will be cited a lot. So please go ahead and do this. But of course, can be a little bit parasitic if people who are doing the primary level studies and having to find everything out on their own to be able to do the studies, don't get cited and thus don't get the rewards from that work. It all goes to the meta-analyst. So you have the DORA declaration, which is kind of a policy that funders, universities are increasingly adopting to say, but also researchers individually themselves are adopting to counter that, to say, well, of course you're citing your meta-analysis, but also make sure that you cite the first pioneering study that first established that effect, so that you also reward the ones that really. Yeah, so of course, yeah, so meta-analysis is also empirical work, but doing something for the first time, finding everything out yourself, sticking your neck out, is also something to be rewarded. So the DORA declaration is one of the ways to counter this. So we talked a lot about this, the fundamental rules of open science, transparency, which is a great way to invite others and to know that others may be able to see and judge your work, which for most of us with a conscience helps us to get the best out of ourselves, out of the things that we are given. So this is one important rule. The availability and free nature of open science work. And of course, you need to think about, things cost money. So what's the solution for that? But to be as available and free and out of commercial profit as possible. Accessibility, which is kind of closely related, but it can be free, it can be available, but nobody can understand it, nobody can read it. You put out your syntax or your code, but no explanations, no what is this step doing, what is this step doing. Yeah, then it's available, but it's not really accessible. Or you put it out in a format of a computer program that nobody uses anymore. So these are all kinds of things that still need work and reusable.
And I think it's also a good tool for researchers to learn, because we learn when we have that.
Yes, exactly. So open science movement, I think it's also in there is also much about the training that we do and engaging and the training we give to others. So I'm now giving training. You will be giving training to your students if you advise students, and they will, so to be able to clearly communicate about these practices and where you can get them, where you can find them, what's the underlying rationale for it, is clearly also part of making impact. So wondering about impact, wanted to get your thoughts about that. So let's go there. Next question. So this is a closed question. I will also switch the screens again. Where is it? Here it is. So I just wondered what your experience is in your neck of the woods. So it's the same Minties. Yeah. Oh, you closed, but you can go in again. I think it remembers. So 2 answers coming in. In order not to influence you, I will show the results, of course, if we have enough response. So 11, also 12. Well, number is increasing. Let's see. So yeah, it's mostly agreements here, at least in this group, small sample, with the statement that it shapes the research culture in your group, which is, would be kind of the ideal end state of this movement, but also a lot of people in the middle. There's a long tail on a frequent topic with the supervisor. Some people who've been talking may have a supervisor who's talking about it all the time, maybe horrible as well. But that's also mostly not a very frequent topic. Characterizes the work as kind of, and as well, a strong belief that it can improve the work. So there's still room to grow and develop, I think. And interesting response to the question about topic of conversation with supervisor, because there's one study being done in the Netherlands, and that was not particularly about open science, but it was about questionable research practices and the extent to which researchers engage in those, and what are kind of the factors, institutional, personal, that are correlated with questionable research practices. And one important factor was mentoring. So mentoring is never about, awareness of questionable research practices and ways to counteract those. Then that was correlated, was associated strongly with the extent to which people reported engaging in those practices. So, of course, we cannot interpret it causally, of course, it's cross-sectional, but it seems to point towards the direction that mentors may have an important role to play. Anecdotally, you sometimes also hear stories about early career researchers who are much more aware of these things than their mentors, and are seeking for ways to educate their mentor, which of course is what should characterize any good teaching relationship.
You don't feel the lattice of the open science. Most universities have a very large database library, so it's not the whole students or the agenda.
Yeah, so are you saying because you're in a university and you can read all the journals,
yeah,
then open access may not so.
Yeah, it's not open access, but my university, for example, has a very good online library, and you can read almost
that's That's true, but you know, we do a lot of work with people working in practice, and they complain, rightly so, that they cannot even read the articles that we are publishing. Now, the Netherlands has you know, made a deal with publishers, so almost everything that Dutch researchers are publishing is now also open access readable. But in many countries, I think Germany is also has struck a good deal. So countries are following, but it's not in every county the case. And yeah, so you really need to feel it and see it and talk to people who want to read your stuff and can't, that you can see that this is a problem, and they're still paying for it. So yeah, indirectly through your salary. So it should be an issue.
And we also need to make it accessible to society, because people believe in conspiracy theories about it. If there's some motivation to read, it will make sense for them. Maybe the percentage is lower.
Yeah, that's an interesting question about whether public and transparency may also help to counteract misinformation or disinformation or conspiracy thinking. I'm a bit skeptical, given the forces that we're working against. But, yeah.
But the community.
Yeah. Yeah, I do believe personally that engaging. Yeah. Yeah, so yeah, so on its own it may not be enough, but if you do engage in a public dialogue and education, and also engage in discussion with people who may have a different opinion, but are able to point them towards openly accessible material, then you're in a stronger position than if you have to say, well, I'll take my word for it. Yeah, you're right. So there's still some way to go. So let's go back how to see how we can do this. Where are we here? Yeah. Alan and Mailer some years ago made a very helpful kind of cost-benefit analysis, and it's important to take in mind. So we can only focus on the upsides of open science, but if you are going to use it, and especially in your field, and also when you go into long-term projects, then it's also important to consider the cost and the challenges. For example, flexibility is something that you sacrifice if you pre-register. I mean, in essence, you can still change your idea and change your plan. So you're as flexible as you were, only other people will know about this. They will know that you first thought A and now you're thinking B, and that they may have to question you, why did you change your mind from A to B, and did you do this before you looked at your analysis results, or did you do this after? And is that then reflected in the way in which you are drawing your conclusion? So you're robbing yourself from a little bit of wiggling room that you may have. It has helped people to realize that we may be glorifying hypotheses too much. So like the pinnacle of scientific reasoning is proposing a hypothesis and then demonstrating that you cannot reject the null hypothesis, or or that you can reject the null hypothesis, and therefore you stick with the alternative hypothesis. But like with the child maltreatment study or paper that we discussed this morning, the fact that in our minds and in our writing, people put together all kinds of findings, whether they were based on retrospective or prospective data on child maltreatment, is also may have something to do with, taking too little time to actually study and understand the phenomenon that you're investigating. So doing descriptive work is underappreciated, but maybe, intensively observing and studying in the wild, in the natural fields. It's like what biologists do. I mean, they collect data on biodiversity, but they also go into the wild and see what happens there, or how this plant or this animal behaves, etc. And we are not studying plants or animals, but other humans. And sometimes we're so much abstracted from the actual lives, the actual behavior. So descriptive work is often skipped to go directly to hypothesis, and then it doesn't work out, and we have to bend ourselves in all kinds of ways in order to still make something of that research. So while it may be a cost or a challenge of doing this, it may also help you to realize, so when I'm going to stake my time on a hypothesis, when am I going to actually do this? When am I confident enough that I know enough of my subject that I would really be surprised if I cannot reject the null hypothesis, that it would completely turn around my worldview. Then that would be a good moment to plan a hypothesis test. The other issues are also there: time cost in archiving, documenting, quality control, going to all kinds of groups in order to get data management plans and permissions in order to use data. And then the sense that this is work that is being unseen. You cannot see it from the outside of an article. It's not rewarded. There are no incentives for careful data management, for writing beautiful code with all kinds of explanations in there. Who's going to read this if you just publish your article? So these are costs. They also put out some benefits, and some of them you may not immediately think about. So I thought that would be useful to share it. Of course, a greater good, that there's greater faith in research, like Bourse is saying, protection against questionable research practices. Also, related to the previous point, if it's really surprising that you cannot reject a null hypothesis, then we may have learned something. And so if there are strong reasons to think your alternative hypothesis is true, and you did a strongly designed with sufficient power study, then this null result is actually maybe very, very important and very interesting, and should receive. And so I wrote this editorial, Learning to Love the Null, also mostly aimed towards my fellow editors, but it's so equivalence testing, which is the mirror image of null hypothesis testing. So see whether we can reject actually if the effect is really almost zero, negligible. Can we really state that the alternative hypothesis is really unlikely, which is the reverse side from a null hypothesis test? We test whether the null hypothesis is very unlikely given this effect. Equivalence test is the other way around, is a way to get at really, really important and helpful and informative null results findings, which you're forced to put out once you pre-registered and said, I'm going to do this. This is what I think. Yeah, then you should also publish the null results. You learn all kinds of helpful systems. So this is the infrastructural argument that you may become aware of. GitHub, where people are sitting around the clock, ready for you to ask a question to support you through your coding or your programming. are markdown, in which writing and analyzing are kind of combined in the same activity, etc., etc. And what they're saying is you invest in the future because actually the skills that you learn in open science are skills that are highly valuable, not only in, perhaps not even in academia, but if you go on the market, then you're learning collaborative skills and practical skills that make you a sought after researcher. So things to think about when you're having to make such decisions. So where's my mouse? Oh, here it is. But of course, we also do this for science. So to see that it works, the principle works, you have to register reports where you pre-register your hypothesis test. It gets peer-reviewed on a platform like a journal. And then if peer review is completed and you may have revised your original hypothesis or protocol, you start conducting your research. And then you can come back to the journal with the results, whatever the results are. And it's clear that if you look at the amount of null findings that are being reported in journals, the amount of null findings is dramatically higher in those registered reports, not because it's worse research, but yeah, probably, I mean, it's just a guess, but probably because an amount of 60% null results is more realistic in terms of our ability to really understand things properly than a percentage of 10% null results, which is found in the traditional literature without pre-registration. So yeah, principle seems to work at least. Now, you already seen that open science is multifaceted and there are all kinds of ways to improve your work. So I already told you about best practices research as a heuristic that you can use yourself, also working at your research yourself or with your group. If you want to try to make things better. So it's a method for defining a process that you want to improve. Let's say you want to improve recruitment, like your question, how do we recruit, but perhaps keeping participants in could also be a process that you want to improve. Then you need to define on what basis do I call a practice a best practice. You would say, well, I want, for recruitment, I want a lot of eyeballs. If I have a practice that reaches a lot of eyeballs, then that's a good practice. But also I want low selection bias, and also I want to control for low self-selection bias. Let's say that these are your criteria, and then you may start looking for practices, asking your colleagues to nominate practices that they know that they consider to be potential best practices. For example, the Capture group, it's a research group in Amsterdam, and has been working in there, highly successful in reaching eyeballs. If they put out on social media a call for participation in a study on birth trauma, they immediately get 1,000, 2,000, 3,000 participants. It's quite amazing. Whether there are best practice in terms of low self-selection bias, I'm not sure. And so, but you may look into their practice in terms of best practice for reaching eyeballs, and then look in what's, for example, the impact network does, and what's the impact network. I cannot remember anymore. Sure.
Thank you. I'm wondering, what do you feel about qualitative studies for best practice research? I don't know. What do you think?
Yeah, so for example, if you could also apply this best practices research,
Yeah.
if you're aim is to improve the process of qualitative research. I mean, there are lots of things in qualitative research, decisions you need to take, which can, be better or for worse. And especially because training in qualitative research is often hard to obtain. Much more training available in quantitative methods than qualitative methods. So perhaps best practices research may be even more useful to do when you're a qualitative researcher, because it's a flexible design. It's less clear cut what's the proper given, design analysis method, recruitment method is. So and your positionality, for example, may determine a lot of the criteria that you want to apply for calling something a best practice or not. So I can definitely also recommend this as a way to improve qualitative research. Yeah, the Impact Network is a network of research organization in Australia and Oceania, where multiple centers working around perinatal mental health. They combine their efforts, they coordinate their efforts, and they decide on the basis of a kind of research agenda which are our priorities, and if from a certain center a study idea is being put out, they throw around their weight and say to all the other centers, we think this should be prioritized. This is a good idea. Can we please do a multi-center trial or a study so that you get your recruitment and also get lots of buy-ins from participants. So which is another way in order to reduce selection bias by having it more centralized, the decision-making about recruitment or not. So let's see some issues that people have tried to improve or saying, that need to improve, and how people have been trying to do this. And I will focus, I base my selection on these kind of criteria for reducing wasteful research. One is it should reduce a lack of reproducibility, which is mainly about the methods that people should be able to reproduce your findings if they just followed the same steps, used the same data, the same code, and replicability. So if other people kind of get the same answer to the answer that you got in answering a research question. And one issue we already lots of you are familiar with is pre-registration. This is kind of similar data showing that it makes a huge difference if you do registered reports, which is kind of the most difficult open science practice in getting actually before your study out there a protocol peer-reviewed. That has a dramatic effect, very difficult to achieve. Not many journals offer registered reports. I just saw in my email box an email about, our own journal was struggling with this. And there are all kinds of pros and cons. But there are also more accessible, more easy ways to pre-register or register. And this is, of course, for the non-clinical observational research, because for clinical research trials, registration, pre-registration is already broadly accepted as the only way in which you can justify clinical studies. So it's kind of so normalized that people don't even talk about it anymore. But outside of the clinical trials, it's still something that people are struggling with, but which clearly has a benefit. This graph represents the proportion of true hypotheses people have been putting on paper and the achieved statistical power that you would need in order to produce at this rate of positive results. And so hypothesis being kind of accepted, which is clearly almost an impossible, highly unlikely that these studies, non-pre-registered, would be done by researchers with such acute insight in the human condition that they only formulate correct hypotheses, and the funds for doing the large-scale studies that have enough statistical power. So most of us are more in this range, and then this rate of hypotheses that are actually being accepted is much more realistic. Now, yeah, sure.
Have you encountered, or I came across something, there was PhD student and registered protocol, and then went to publish the findings, and the Birmingham came back and wouldn't publish, saying it would send a plagiarism. That the search strategy was identifying it as being very, of course it was different. It was, it's in study that being published. So, has someone can come across in Europe or yourself?
No, I've never encountered that that the journal would say this is duplicate publication. And so also, well, self-plagiarism isn't really plagiarism. And so the whole debate about this, and especially if your paper is kind of the elaboration of a previous registration, it's not expected that you totally rewrite all of your ideas and any of your text. And so it's in my experience, it's clearly seen as a plus, as a quality sign that this study is based on a pre-registration. Yeah, I believe then that those editors should be educated. Yeah. What? Yeah. Of course, what can happen is if you pre-register a hypothesis test or analysis plan, and the paper that you write on the basis of that has a different hypothesis and a different analysis plan. And that can be okay, but you need to explain it. And if it's not explained, an editor might say, and I've also done this, explain this, or otherwise, if cannot be explained, I cannot be sure that this is really a pre-registered, so that the order of things is really according to the pre-registered plan.
What if we challenge it and got the publication on a challenge, or it's gone back to the public and got published, pushing quickly, and the other is still working through publication again?
Yeah. Now, my experience actually is that reviewers compliment authors when they base their research on pre-registration, so that your chances of publication are being increased if it's based on pre-registration, and you stick to the pre-registration or explain any changes, amendments. Yeah, so it depends on those conditions, but still, it's seen as a quality characteristic. Yes.
Surely, if you're publishing your strategy, it's so that other replicates. And if you just say in your publication, took whoever's out search strategy,
Yeah, so the question is there a problem if you use your own, or even if you use another person's search strategy.
Using the exact
Yeah.
search strategy, and like that's why you're putting it about that, like it just seems like a vicious kind of circle then, like you're putting your research out there, but then you're told that you're plagiarizing people or you're plagiarizing yourself.
No, that's why I say those, if that happens, the educated should be educated, because what is happening now in major journals is that also systematic reviews need to be pre-registered, also to avoid that many people are doing the same meta-analysis at the same time. And so people register on Prospero, for example. But also to demand that search strategies, search strings are being shared as an appendix or supplementary material, and of course, depending on the license that you give, it can be reused. Yes.
Yeah, this is what I was gonna ask. Like, say if Sylvia published a good time review 10 years ago, and then I decided I'm gonna rerun it now, see what else has come out in 10 years, and I want to use the exact search strategy, but like I correct Sylvia.
Yeah, sure.
Surely.
Yeah. So Sylvia wins because she gets another citation. You win because making a good search string is very hard, difficult.
Difficult
Yeah.
situation then, because you're using someone else's work, even though you're crediting.
Yeah, I don't believe in general that is seen as or frowned upon. Actually, it will be encouraged. Yeah. Yeah. So the only thing to bother is to think about, where to pre-register. There's a range of options there. Somebody hopefully made a table for it. In the beginning, you have As Predicted as a platform for pre-registration. It has some advantages, downsides. I mostly use OSF because you can get it in two ways. There's a template, which is kind of easy, but and also kind of describes the consensus among the people in your field doing that type of research. That these are the things that you need to know in order to be able to judge the value of research. So it extracts the collective knowledge from our field and puts it in a template, which can make you look smarter than you already are. But if you're doing something really unique that there's not yet consensus about, then of course there's also the possibility to use an open registration and put the things in your registration that you think are important at that stage. And I made it. Oh, sure, yeah.
As predicted, I know that there's a template on OSF code as predicted.
Yeah.
Separate site as predicted where you come.
Yeah. So you can pre-register it on the As Predicted site, but you can also use the As Predicted template to pre-register on OSF. Actually, when I looked this weekend on OSF, and perhaps it already changed. So I did a search for, are there any registrations or research on traumatic childbirth or birth trauma? There were already 13 registrations on there. So there's the one on, by Amelie, who's working on a paper with people from COST. There's one on validation on a scale. So it's not even always hypothesis testing research, but it's also more descriptive or methods-oriented work that people register. There's a scoping review. So even a scoping review, you can also pre-register. At least people then know that, okay, there's already a person doing the scoping review. Cross-sectional survey. So many examples here. Laura, you're also in there. on a longitudinal study that you pre-registered. So I wondered, you know, I won't survey all the experiences with pre-registration, but was it like a difficult process, or did you encounter specific challenges? Can you comment a little bit about this?
But then.
Oh, the microphone. Could you share the microphone?
I found that. Yeah. I think there's a. But it's unlike.
Okay, thank you. I think it really depends for me, at least, on the template you use. So for those two, I use the as predicted template. I find that quite easy because it's like simple information, and you can kind of use the sections not as you like, but they're more broad, so you can adapt it to your study more easily. But then we used another template for another study, which is like a specific one for secondary data analysis, which is really, really elaborate with lots of sections. I found that quite difficult to adapt to your specific study. So yeah, for me, it was mostly the template, but I find OSF quite intuitive in general. Like, I find it okay.
Yeah, and also the point at which you did the pre-registration. So how did you decide the moment that you said, well, okay, now I've thought long enough about this. I'm now confident about my questions and hypothesis. I'm going to put this down for posterity forever.
Yeah, I think that's for me the biggest advantage of pre-registration, because you really make yourself think harder about the whole process and what you actually want to do and how before you start with the work. And I think that's always a good idea before you start your analysis, at least like when you write your introduction before, okay, that's probably not a big problem. But yeah, before you start your analysis, to really get all the knowledge you need and then put it down in writing and upload it.
Yeah, so sometimes it feels like it's more work to do a pre-registration as part of your study. But what you're saying, well, actually, it's doing the work, it's doing the same work, but perhaps in a different order, or you do some of the thinking earlier, sooner rather than later. For example, with regard to your analysis plan, which may even prevent you from having to take detours or going to unsuccessful cycles of revision because you've thought about these problems beforehand.
Yeah, definitely.
Yeah, of course, but still, if you pre-registered prematurely, yeah, then you need to do extra work because you have to explain why you then were wrong the first time, and it may be better this time. So there's already, work on this, and you can go on the website to see what else is there and is currently happening. So we heard already a little bit from Laura about possible hurdles, so we'll skip this for the sake of time. What Lara said about pre-registration in secondary data analysis, or you can keep it there. Okay. So what's the difficulties of pre-registering secondary data analysis is kind of also is difficult about pre-registering longitudinal research, unless you are part of a longitudinal study from the beginning, where you are not exposed to any of the data pre-registration. But usually that isn't the case, especially in larger projects. And not all of your ideas and hypotheses may already be known at the outset of your project. They may develop later on, especially as you build and extend your your project. So in terms of longitudinal research and pre-registering, you will mostly be using the template for secondary data analysis and kind of go to the same steps of, can I actually, I think you wrote something about, well, it's complicated in terms of, yeah, of course. Yeah, it's open, so I can read it. And so prior knowledge of the data, yeah, that's not a clear-cut yes or no answer if you are doing longitudinal work. Still, there are potential solutions against transparency is, of course, the first step. So you're not pretending to haven't seen the data or part of the data before you do the analysis. Sometimes, yeah, you go to different iterations of running your data analysis plan and changing some things. And sometimes you think, well, is this method better, or is the other method better? Is this way of imputing my missing values better than the other? I don't know. I can try both. And then, would then my final choice be based on the results or the superior method? I don't know. Multiverse analysis, which is kind of a systematic generalization of sensitivity analysis, may be a way to address that problem. But there are multiple ways that pre-registration can still work, even if it's not so as pre-registration of a single experiment before you are actually conducting it. So people have been thinking about this, and this is also a great paper by the same J.C. Baldwin. She's been very productive. Protecting against researcher bias in secondary data analysis, if you're looking to do those types of things. And another, in terms of best practices, so already people in birth trauma field are engaging in this best practice, so we can learn from each other and how to tackle those things. Another process is, of course, how you arrive at your hypothesis. So what does it take to be genuinely surprised if your proposed hypothesis doesn't work out, isn't supported by the data? And actually, there's a great paper on a scale under the title "Why Most Psychological Research Findings Are Not Even Wrong." And what she means by that is that in psychological science, theories are verbally stated, and the words and the concepts that we are using are sometimes so multi-interpretable, vague, flexible, that you may use them to almost kind of support any possible pattern in the data. And so which makes many psychological findings or theories very difficult to disprove. And so Karl Popper, turns around in his grave all the time. Sorry? Yeah. Well, anything. But so this is an example also that she gives, the work by Andrew Meltzoff, the idea that babies are born with a strong orientation towards social engagement, and it can be demonstrated by especially tongue protrusion. So I think in the psychology textbooks, there's this picture of Meltzoff with his tongue sticking out, and strong evidence that infants, as young as they are, from a couple of days old, will more often than by chance stick out their tongue after being presented with a tongue by the experimenter. So, like in this picture on the top, so the experimenter presents this stimulus, protruded tongue, and then observes whether there are any tongue protrusions by the baby. And of course, babies, I don't know if you know babies, but they stick out their tongue quite often, all the time. It doesn't seem to be a clear pattern, so you need to control for that. So there are all kinds of control conditions, different stimuli, and different behaviors to observe, in addition to tongue protrusion. And so, while generations of psychology students learn that these infants are highly sociable from birth on, they're kind of coming to the world, ready to engage with other people, and this is what Andrew Meltzoff demonstrated with a famous study. It could be replicated. Infants protruded their tongue, but not significantly more so after the experimenter put out the tongue than after the experimenter did other things. Of course, Meltzoff still alive and wrote back. So wrote kind of a paper criticizing and saying, well, but this experimenter was unfamiliar, was unfamiliar, and it may work only with familiar people. Well, that goes against the theory that this is the mechanism to which babies actually get to know people. How does that then work? How is that consistent with that theory? So it's a very interesting case which you might want to read up. So these authors, Oostenbroek and others, they then wrote a response to Meltzoff. So it's three-way, and kind of wiping the floor with him. Which is an important demonstration that the clarity and concreteness of a hypothesis or a theory is actually something which is really, really important if you want to be able to actually learn from research. Now, formal modeling of effects may be a way to achieve this. So this morning you saw the directed acyclical graphs, kind of conceptual modeling. I guess many of you also have experience in making these kind of schemas that are a very good step towards actually designing your study, operationalizing your variables, and drafting your analysis plan. Here's an example from Lara again, who is so what was this again, Lara? I think this is from the pre-registration, I believe. Yeah, it's not published yet. Yeah, so and so you've formally modeled your theory here in this.
Yeah, that's just the
Oh, yeah. It's you referenced Lederman because you used a formal model, in this case the actor partner and mediation model, which is a way to deal with the fact that you can say it better yourself.
I think you were on.
Oh, yeah. So yeah, and self-reports and reports about the others can have different meaning, much like retrospective and prospective report can have a different meaning. So the actor partner interdependence model with the addition of mediation is kind of a way to have a formal a priori model that makes a clear distinction between reports about you and reports from yourself about yourself, and use, if you collect all these data, use that to get a better sense of what is actually the meaning of those measures. So this is a great, also best practice example in our field. Another best practice is also to be realistic about effect sizes. Something to make you aware of is that we're recently seeing and understanding that perhaps due to the selective bias of all the positive findings in the literature, our kind of intuitive benchmark of how strong effects are of psychosocial factors may be totally wrong and may need to be corrected by orders of magnitude, which has concrete implications for the design of your study. Because if you formulate an hypothesis, it's only informative if you have sufficient statistical power for testing this hypothesis. You need to have some sense of, how strong the effect will be in order to know how large your sample need to be that you need to collect. And we have been setting perhaps these effect size expectations too high because we are led by a literature that's biased, also because it's costly, because setting effect size expectations lower means you need more participants to achieve the same statistical level. But we cannot escape the fact that if you look across different literatures, so Vander and other looked across the whole field of psychology, and there are some differences in subfields. But in our field, individual differences, the average effect size is in Pearson correlation is about 0.20. Whereas if you remember in psychology, people often refer to the Cohen's benchmark, and Cohen's benchmark is 0.30, is like a moderate size effect, which is a large effect if you look at the total distribution of effects in our fields. So people are saying in their sample size justifications, we expect a moderate effect of 0.30, and then I need a sample of 85. Yeah, you may then already, even without knowing it, be underpowered to detect an effect, even if it's still there, but which may in reality more often than not be weaker than the 0.30. And this is a very pervasive problem. And perhaps this is, cognitive dissonance may also lead us to appreciate the small effects a little bit more. But yes.
Your intervention or anything to be good enough to be applied.
Yeah, so that's also a very interesting point. So this is all kinds of effects, observational and experimental, and then you get this kind of average effect. It doesn't say much, and so actually what they say is don't accept our benchmark of 0.20 as the most probable effect size that you would get if you don't know anything else. And we also did this for the attachment field, and we came out miraculously the same kind of distribution of effect sizes. But they also say, look at the practical implications of the effect size. And what you're saying is that for clinical guidelines, there may be considerations why it's just not worth the time and the investment to apply interventions from which we know that they have quite small advantage. Of course, but whether that's the case, it should actually be a cost-benefit analysis done for that particular intervention, for that particular outcome. For example, aspirin is famous for having a very small effect size, but if you do it in a public health kind of way and prescribe it to many middle-aged men, then you're preventing a lot of deaths. So then a small effect size with low costs is clearly something that you still want. But psychotherapy, of course, is very expensive, and you may not be able to give that on a public health scale. So perhaps then the bar needs to be raised. But that's actually their message, is to really think about what does that effect size actually represent. And then perhaps, some small effect size may still, because it's cumulative, be something that you want to be interested in, empower your study on. I didn't find best practices in our field for how to set expected effect sizes, but if you come across those, please let me know. Just putting this out there, just to make you aware. So reproducibility, code reproducibility. So people not only have to publish their article, but they have also supplements, and sometimes they include their the syntax or the R codes that you use to analyze the data, and sometimes if it's possible, also give the data itself. In principle, so that everyone can download it on their computer and then run the same analysis with the same code and see that the results that people are reporting in the article are really the same as they are getting on their own screen. Well, they've done this on studies that used a data repository from Harvard University, where there's kind of unitary requirements for uploading your data, uploading your analysis script, and then did this for 1,000 studies, and then run the same analysis again in that kind of environment that they built. And what you're actually seeing is that the success rate was, not so very great. For all kinds of reasons. R files with packages that aren't used anymore, but with undeclared dependencies. File paths that may be local and then, don't work on a different computer. Even if you see there is open code, open data, it's not immediately means that it's also reproducible. But there are steps you can take yourself in order to promote this. So now there are some basic code practices like making narrative code, or even if you use R Markdown, write your article in R environment with including the analysis codes on the places where you want your results to come, which is the best way, I guess, to do this. So your papers actually produced together with the statistical outputs as you're writing. But of course, repositories and journals can also take steps in order to really do their jobs and don't always depend on the carefulness of individuals. Another thing to be aware of and to try to develop best practices on is the phenomenon of overfitting. And this is especially relevant for longitudinal research in psychosocial factors, where you may have a lot of variables, all kinds of birth-related data that are being collected and you may be interested in, for example, building a prediction model for who gets PTSD or who not, or other types of outcomes. Like this graph says, you can fit a simple regression, but people then think, well, it's not always a linear correlation, so I can try to fit other higher order regression lines and try whether that also fits the data. And of course, the chances of that happening is hitting on something is higher in small samples. what's the problem with that? Because you have a fitting function, it fits the data very well, you get good fit statistics, so it's like success. The problem is, of course, it's highly specific to this particular data set. It may not replicate very well to other non-observed data sets. So one way to address that is to include cross-validation in your work. Is for the sake of time, just going through some examples that I found. This one is from Greece, who built a prediction model of PTSD after a cesarean section. So they used data science methods in order to just train an artificial neural network to optimally predict diagnosed PTSD after C-section. And well, for prediction models, you need to look at precision. You need to look at the sensitivity, which is also in computer science called the term recall is being used, specificity, and overall accuracy. And what this graph shows is that, and the goal is to have, to look whether you can still have a good prediction with as few predictors as possible. And they could get pretty good predictions from having like 7 aspects of the birth, which were in their data sets: emergencies, cesarean section, pathology, preterm birth, being on an NICU, absence of breastfeeding. And so in their data sets, these together combined in a good prediction model of PTSD after childbirth. And I included cross-validation, so having first a training data set and then cross-validating that in part of the data that they had set apart for testing the prediction model. It's a pity that they didn't use open code, so they reference some packages and Python programming that they use, but it will be very difficult without contacting the researchers to reproduce it. Also, the data availability, upon reasonable request, but no place, no DOI or permanent identifier for where this data is residing. But still, cross-validation being used in order to tackle the problem of overfitting. And it seems that in computer science, there's much more awareness of that problem than there is in the more substantive area. Another example that used narratives. So women wrote down a narrative about the experience of giving birth, with the idea that perhaps words that people use in such a narrative may be predictive of later PTSD, and also trained a model also based on natural language processing to try to as correctly as possible predict which women were most likely to be later diagnosed with PTSD. Very interesting study, also including cross-validation, but no open codes, no data availability statement. Well, the paper still has to be published. It's now a preprint, so perhaps in the final publication we will see this. And purely for descriptive purposes, interesting to see the types of words, because you can also look at the type of words using vocabularies that seem to contribute to correct prediction of a later PTSD diagnosis. A best practice in terms of the cross-validation inclusion in that work. Just to wrap up, two final things to say. I think this morning we already talked about the importance of getting buy-in, getting engagement, and this links back to one of the principles also behind open science, is that it's for public good, public benefit, not necessarily only the benefit of the researcher and his or her career. So, and including stakeholders is one way to achieve that. So it should not only be a good idea to do the study for you, but also for the people who concern this. I've been doing research on women with intellectual disability and looking at things like conception and abortion rate and risks. It's very important to also talk to people in order to get at how that makes them feel and what they see as possible risks of the ways in which this information may come out in the open and may feed into certain stigma. When you do so, we did another study looking at an intervention. We got so much support that it was very easy to recruit and retain these families, which often have to deal with lots of difficult stuff. But we're still able to retain them very well in our trial, because they were really seeing how important this intervention study was for also the whole discussion about them as parents.
How many people were involved in that study?
Sorry?
How many people were involved?
Yeah, I think almost 200. Yeah, which because it's a very small population, it was significant. Some things that we already discussed. So the joining of consortia, so I mentioned the impact as a way to the field to organize itself so that the step towards doing research as a consortium is made more accessible. But of course, there are multiple ways to row. I mean, you can also decide that if you have a great idea for a study here, perhaps it may also be a good idea for Dresden or Munich or Istanbul or wherever. And one way, cost network can have a lasting legacy is, of course, people sharing their protocols, sharing the instruments, sharing their design ideas, and creating opportunities to be able to combine and share data to tackle some of these issues that we discussed. So multi-site replications are, of course, the most strongest form of evidence, and actually can increase the informational value, because you can also look at the role of context and circumstances and culture and time in interaction with some of the other local variables that you're maybe interested in. Finally, it can look daunting to approach your work in an open science kind of way. This is a nice paper by Katawala and others, easing into open science, and where each of those practices are also kind of graded in levels of difficulty. So starting a journal club, exposing yourself and others to different types of research, different ideas, different designs, methods, etc., to become more aware is very accessible, and it's fun, it's nice. So we're doing this in this training school, but we can, of course, continue to do this at home. Well, project workflows, etc., then pre-registration, maybe some a little bit more difficult. Registered reports, that's very difficult, highly rewarded, but Preprints, that's very easy to do. You can always do this. There's lots of information, on the policies of your journals, how you can do this without diminishing your chances of being published. So I don't see it as an all or nothing affair. I think that's the most important part. It's also in this sense incremental in how you can use open science in order to increase the validity and quality of your work, and produce papers that no editor can ever reject. So that's it from me. So some drinks have come in. Where are we with time? So sorry. We already had some discussions. See some tiredness. So shall we take our break now, and then before we then go in the group assignment and explain that, well, let it sink in, and perhaps take the opportunity to discuss some points you may want to raise about this, and then go into the group discussion. Is that a good proposal? Well, let's do that. Yeah. So we start at 3:15. Right. 4:15. Yeah, sorry.